So a major problem that a lot of people with disabilities have and more is suffering during snow. And it's not just roadways, but it's pathways and stuff. But this also goes into not only suffering, but I want to add it also goes into other things like leaf blowing and stuff like that. Now, some places do a little bit of suffering for you. You can hire someone else, but I want to look at some more technological solutions to perhaps do this, which may become less relevant, ironically, due to global warming. And that idea I want to present is an idea for a robotic kind of snowblower and some stuff we could do with it. One thing that I believe we could do with a robotic snowblower to make it a little better is that we could have the snowblower have built into it a heated contact. So it could have a strip, and when it touches the ground, it's slightly heated, so it can more easily scrape up ice and push out of the way that might cause people to trip. It doesn't have to heat up a large surface just at the contact. Also, it can more easily peel off snow and stuff that's stuck to it. Just a very thin wire. Another thing along the lines to make this whole thing better would be to have it have any adjustable treads. So normally treads are made so that the treads are, like round tanks. A lot of treads are just like fixed with all the wheels and stuff. But if you have the side wheels also have suspension and the bottom wheels, and you have all the suspensions connected together, so like if you have a liquid or a gas or something, that all of them are pushed together and the liquid flows from one area to another area, well, what happens is that the thing can, if it goes over a bump and the two tires can squeeze together on the bottom close together, and the top tires can push out, keeping the treads nice and secure no matter what it is. I would draw a quick example of this. So, like, this is it normally, and then if it hits a bump, these two wheels get a lot closer together, and these wheels on the outside will get farther together. Now when they're farther together, that also keeps the more surface area in the part of the tread that is at an angle, like an upside down trapezoid, becomes flatter. And the reason why treads are better with snow and stuff is treads really can help you navigate much terrain, because they can provide a lot of surface for grip, and that can help you during bad snow and stuff like that, or during slippery snow. It also means that it's less likely to fall down too deep in the snow, or on ice, or something like that, or on surfaces that are loose. It will move the surfaces a lot less. Another thing that you could do to the treads is, instead of using pneumatic and stuff like that, a pneumatic is with air, and hydraulic, which is just any liquid. Once they're all attached together, so the liquid can flow in one thing to readjust it, is you could use the idea I've had before, talked about using electronic controls. An nice thing about electronic controls, comparatively, is that electronic controls itself would mean that you can pull in and stuff with adaptive stuff, so you can sense stuff far away and see the object and pull in one of the wheels or loosen the wheels before it hits the object, or just the amount of tension. Now you can have an in-between one where it's not all fully pulling with electronics, but electronics where you have both the mechanical one of fluids and stuff going up, but also electronic one where pulling in and out. Now the hybrid might be the best, because it can be hard to predict in snow and stuff what bumps and stuff it's going to hit, because the snow really covers it. Snows can have different density and different properties that are really hard to detect. You also might want to figure out how to make, you'd also have to figure out something that doesn't leak very well too much, but still reaches TP suppressor. And I think I've talked before about this, but maybe maybe instead some of the fluids and stuff in it are more solid and more of a gel and stuff that can be pressurized and push the stuff up and down, and not all of it's the same fluid with nanomaterials that also have a higher surface tension and will leak less, while still flowing very easy and doing the tubes. And you can also adjust the viscosity using magnets and stuff. You could also, if you want to make them a little better, the fluid threads, you could have it adjustable where you can pour in fluids actually into the system to make it harder and less. Another thing for this robotic snowblower design that I want to put out there is maybe making it have a renewable, is having a battery station. If you make this whole thing battery powered, battery power for a robot is a lot easier for it to control the electronics and stuff. Electronics are a lot more adjustable, they tend to be more durable, they can work in lower temperatures more often, except for there are sometimes problems with batteries, but people have worked really ways around that, so a good battery will be fine. The problem is that what if the power goes out? So a way around that is obviously to have a backup battery power station that somehow I could go to. And this backup power station could even have solar panels or wind power to power it. Wind power is not as power dense as solar power by far, less than a tenth oftentimes, but there's times where this might be better for this particular use, in that wind power, when is going to be most high during bad storms, and during also times when the sunlight is blocked out, which is going to more often be during times of very bad weather. There's going to be a lot more sun that's going to be blocked out. Now, also a problem that people can bring up with wind turbines and stuff is that wind is not, how would I say it? Wind turbines, if the weather's too bad, they have to slow down. That is true. You can't, if the wind is too fast, you can't use the full energy, but that's due to mechanical issues and stuff like that. And on a smaller scale, faster turbines can be made significantly stronger. So the whole thing about slowing down a turbine, when you have to do it, because you don't have the same breakage. So you could really use these turbines in very, 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 very bad weather events, and you will be totally fine with everything that this turbine would potentially do. So I think it's a great possible idea. And during good weather during the year when it's not snowing, this whole system could be used to help power your house or other things. Another idea is to make this a public service in some way. So either you could have a company do it, or your neighbors do it, and you could share it. So have a company do it, which is still private, but you would have to save a lot less money to do it if the company does it, and you're just renting out the service every now and then, but it's not as accessible. You could share one in a co-op fashion with your neighbors or something, or a couple of people. You could have the government do it for a wide range and really make a sophisticated one and save a lot of money and give it out. Or give it out to people that are disabled, or for whole communities or something like that, and look at it that way. Or you could have some mixes with government subsidizing private or people buying it, and a variety of complex mixtures, some of them which I obviously won't mention here because just time-wise, and that I haven't also thought of all the different ideas. Also for public services, you could always have the idea that, not private, but just community and charities and stuff like that. With this technology also, if you add a smart system to adjust how much power it's going to different things, you could save a lot of power. So you could adjust the horsepower with the treads and everything. And if you have the treads running at higher horsepowers or something, when the treads are running at higher horsepowers, they use up more energy, and it also is more wear and tear. When the snow blowing part of it is using up more power, it is also going to be significantly worse. But when everything is, but when it's using up less power, it can do less. Now also, power can also make it last longer by just heating and melting some stuff in some cases maybe. But the whole idea about power adjusting is also nice that way. Also, lowering the power means less noise and less disruption to the natural environment. And also less energy is more environmentally friendly. So power adjusting could be a huge thing, benefit for this. Another idea along these lines is what I'm going to call ice jars, but it could be that on the bottom to help put up and just not on the top is that you could have different pieces that are like clippers like you see on hair cutters and stuff, where they just go back and forth. And it's hair clippers going back and forth. What they could do is cut up the ice more easily with less energy and cut up also hard snow. And yeah, just like imagine like clippers that go back and forth like you see in hair clippers. You could also imagine this technology also with the snow blowing thing, where instead of having one big thing turning around, you have a couple little things turning around that sort of a little bit engages with each other. Then you could also make it more forward facing and less wide. So instead of having one big circle that's like 2R and have to make it 2R deep, you can have two circles on top of each other that both are and have more contact to really chop stuff up. But this could use less energy. That might chop stuff up better, but this might use less energy, the bigger one, by because you don't have to hit the same area. But then again, you do have to turn it through the whole thing, so that's complicated. Does this pick up the same amount? How much energy compared to the uses this one? Was picking up smaller chunks, but faster, and how it cuts to it. So maybe you save energy, maybe you won't. I really would have to think about that for a long time, and probably have to do engineering calculations, and probably there's a sweet spot, and it's not that simple. Another thing is having this whole thing where it's spraying. Also, with the small one, you might save energy because it might direct them more in a certain direction, like up or something. Or the two different saws one of them might push them more up and one might push them more side, so you could have more adjusting there. I just thought of something just to think about. Another thing you could have is different ways to adjust the action. It's called clippers, but I shouldn't. But adjust the action of how much it is spraying out in a certain direction, because sometimes it doesn't need to spray that far, so you can save a lot of energy that way. If it's doing a little bit, it could use less force in a section. So splitting up into different pieces with different spraying mechanisms could save a lot of energy, but also make it safer, because you might less likely hit something by mistake with a lot of force and break it. It can make it more quiet. It can make the whole thing more durable because you're using less energy. But another way you could have this whole thing adjust its ability is if you have different blades that are digging into your soil. So imagine that you have a bunch of blades in a circle. These blades in circles are what impacting and cutting it. If you have it, each of these blades can also rotate. You can adjust that so you can have the blades go more dig into it. Then you can have the blades more point in and turn in a different direction to throw it, and so on and so on. So, for example, if it's going down, it can have it mostly going down vertical. Then when it's scooping it up, it can turn 90 degrees, so it's more scooping up the whole time, like this. And then when it's flowing it can adjust again. That can save a significant amount of energy and also work better into scooping it. And it might also decrease wear and tear as it needs less energy. And we already have a lot of things that do this in very high performance things, such as tilting of helicopter blades is really important, and you can do that thousands of times a second, and so many other devices. So I don't think it's that complicated with electric motors, which tend to work better than non-electric motors for all these uses. A more out there idea I have is a Stirling power station. So Stirling energy. So Stirling motor or Stirling engine is a device that converts heat energy into mechanical motion power. It is the most efficient way of doing it, or one of the most efficient ways. It's an external heat engine compared to the internal combustion engines you see, or external combustion engine. And by external means that you don't burn the fuel inside or the heat that's inside. It heats up the energy engine from the outside. It means you can really use a wide variety of fuels, from oil to wood and stuff, to solar power to geothermal. The problem with it is that it's not good at it's adjusting really fast to like speeding up or slowing down. It is also a lot more heavy and bulky. But for a set power station, that's not as big deal. And with making it a small one, it can go up and down a lot faster in its power abilities. And also now there's better designs with acoustic ones using better materials and stuff. So to work with that. But the reason why I put stirring one is if you want to power this stirring back out with gas, you could have recharge the battery pack that way. Or if you want to power it with wood or whatever, you could use a wide variety of fuel. Or connect it to your wood stove or something to power this whole system. So it just would not be limited to the normal things you think of. I've done several videos on stirring power that I recommend you look up. Another way to keep this whole thing powered nicely is to if you make the battery pack smaller, there's a lot of advantages in that it has to carry less weight with it. And you can replace the battery more easily in and out if there's a problem. And also if you directly power from the wall, it actually is more efficient because there's less steps of first converting to energy in the battery, then back and forth and all the other electronics in between. So you do save some significant amount of energy that way. But hooking up to a cord can have its problem in that the cord could get entangled and stuff. The cord might not reach long enough, or you might worry about people tripping over the cord if it's actually doing stuff. So cool ideas would be around this at various levels of complexity, is to either have the cord being able to withdraw and pull into the device at different times, and having the battery be attachable or detachable depending on the use case. Or you could have it that it could plug itself in the cord if you want to do a little more fancy, but not too much fancier. You could also have the cord have some. Also, with the cord, you could have different things to prevent people from electrocuting themselves, such as quick detection if it's plugged in or not. So when it's not plugged into the device, it doesn't put any electricity out. There's many ways of doing that. The robot can send a little current just to tell it, hey, I'm connected, and then it can send a lot more current through wires. Then it can measure resistance and see if the resistance is low in like very quick succession. Then if it sees that suddenly when it's pulled out, it doesn't get the feedback that it's plugged in, and the resistance goes up, quickly low turns it off. And this can happen so quickly that it can't really electrocute you or burn anything in milliseconds. And that also will save power from leaking. Then you could have an override of some sort if you want to use it to power your house or something when other devices. And this technology is already used in a lot of EVs with power stations, but not the cord withdrawing part. And if the cord can't withdraw, maybe you have a notification saying the cord for some reason can't withdraw because it's stuck on something, but it's withdrawn partially. And you could have different rates of withdrawing, some from fast and some slow, so it doesn't whiplash and hurt people at times. To prevent freezing of the motors and other pumps, we can use more of a solid Nanoloop, which there's a wide variety. The oldest kind of generation is graphite, which works well at a variety of temperature, but it's an older version that can get more into snow and stuff and more easily off. There's some metals that are self-lubricating, and even now a little bit of plastics. Self-lubricating metals, the oldest one is like pig and cast iron, actually, but those ones tend to be heavier. Even the new ones will be lighter and have a high carbon percentage, which makes them hard, but not that strong. Hard is how well it cuts into something and how dense, but it can put on satin more easily, more kind of thing. And they tend to lubricate because they produce little carbon nanoparticles or metal nanoparticles that self-lubricate. And the more carbon you add to like a lot of alloys, the better it is. You also have now plastics and stuff with similar properties, like non-stick plastics. A lot of them are have fluorine in them, which is not good for the environment, but a little uses here and there might be okay. But we're looking at alternative methods. Fluorine was used to make it non-stick in the past because fluorine is super reactive and sticky. But if you put in some certain things, it sticks so strongly to the other atoms in it, it prevents everything else from sticking, kind of like gets rid of it, because it's bonded so strongly. And nothing else wants to bond anymore. But now the newer generation is like carbon nano-onions and stuff like that, which right now are super ridiculously expensive. But there's a wide range of hope for making them cheaply. And they would also maybe be made with taking CO2 out of the atmosphere. Another one that I want to talk about here is Plusless Motors. And Plusless Motors are electric motors that a lot of things are not in contact with each other directly, unlike motors with buses. And that, because a lot of the stuff are not in direct contact with each other, you get a lot of major benefits with wear and tear and stuff. You sometimes reduce a little bit of the efficiency and make it more complex. Sometimes you don't because of less friction. But you could do this better in cold environments, is my point. Another idea along this whole line is to invent better ways of surveying your environment. Now, some ideas for surveying your environment that may come up with all this is LiDAR and cameras and other technology. So visual cameras, the problem with them, visual cameras are really what we see and would best identify with like what human beings understand, and warnings made for human beings. And with the advantage with the cameras also is they're cheap, relatively, you can put many of them in many different angles. The problem is they might not see the best during a snowstorm and they might give too much data at times. Now, it's not as bad a problem as with cars and stuff because this is operating much slower, and especially if you start early and you're not doing like 20 inches at once in 10 minutes, but like over a sustained period of time slowly. Then you have other technologies like LiDAR, which uses lasers, tiny lasers in a sense, which may sound dangerous, but it's very safe and has been widely used. Ultrasonic sensors and more. And these all can actually map up any region, but you have to figure out how not to make it get too much interference from the surrounding environments. The problem with LiDAR systems is that LiDAR systems you have to find a laser or something that works well in a snowstorm, and there are spectrums of light that can pierce easily through snow, but then you can't see the snow you're supposed to shovel. So you kind of have the problem both, in which way you might want a camera and a LiDAR system. But there's also you can use radar, and figure out the radar that's best to penetrate it. Radar gives you less details, but you can see through the snow more easily. Ultrasonic ones, maybe, but I don't know how well would work in a windy environment with all the little snow particles and particles floating around that might interfere it. So it's something to think about. Now, a simple sensor setup that's often used is to put out stakes, and these stakes will tell you the boundaries of where it's supposed to work on and not work on stuff. It's a very useful idea, but this only tells you the boundaries. This doesn't tell you the snow and everything else, and maybe you don't want to set up the boundary lines all the time or something like that, and that's pre-set up. So that's something that might be useful add-on, but I don't think it should be what the system fully relies on, if that makes sense. So on to the next list. Some of these stuff are a little more out there. Maybe in the future you could have this whole device actually be a snowmobile ride. So when you're doing stuff and you need to get out and you have mobility troubles, or it's just so bad weather, you can ride it. Maybe it can put out sand and ice and stuff. Sand and salt to help clear the roads in little ways. maybe you can have a fast charging setup, so it can just do the whole thing fast charging. Now, fast charging is usually less efficient, not always the slow charging, but in emergencies, that has to do a lot of work. It might be a useful thing. Fast charging usually is run at a higher power, usually current density, but it draws more energy out. And another way you could do fast charging without as much negative benefits is connect the battery pack to mobile outlets, so it can charge mobile outlets. But then you do cause some more safety concerns. With more wiring, there's always more safety concerns. The other thing about this setup with connecting to multiple walls is that it you still have the thing that putting so much power into a battery can sometimes make it wear out more fast or less efficient in charging a battery. Not always, because you're just overloading the system and making it work faster and can respond. That really depends on the battery system, so it's more complicated than what I'm saying. Another thing that this whole thing could potentially do is maybe it could also work as a lawnmower, which would make it significantly more expensive, but it'll be making it more useful, so maybe more people willing to fund it. And it would also save money in buying a separate lawnmower and this device. How we'll make this device bigger, and when you have a bigger device, it might not do the best edge trimming. Also, should we have so many lawns in the first place is a huge question, with them being bad for the environment and everything. But I just want to throw out the lawn mowing idea out there, kind of thing. So we do have the lawn mowing idea. Now, I did not say this, but also maybe more useful would be to have a leaf blow capability, which would be a very interesting idea, in that if it has a leaf blow capability, it would be noisy, but it would maybe less noisy, because if it uses less blowing and more flowing, less blowing, more throwing, you might be able to get rid of a significant amount of the noise. But also, beyond getting rid of a significant amount of the noise, it might add more functionality to it with a little bit more add-on parts. But then again, it can't do the small trimming places. Another idea, kind of along this whole line, is to add a snow blowing attachment or something to cars, into self-driving cars that can clear out the roads for people to some extent in the future. But the self-driving part's much more out there. And to electric cars, you could hook up maybe to an electrical system with some fancy hook-ons. But not all cars are going to have really high horsepower for really bad weather conditions. But it will also make the roads more and more things regular. And then if you have a satellite above, you can see which roads are better or more clear or not. And the satellite hookup with all these devices, and even with the snowblower, if it's a public service, might lead to better ways of figuring out who does what and what gets done faster, so more roads and more sidewalks are clear better. So now, another one that's a little more out there and a little more is to make snow bricks or ice bricks, where it compacts it and throws it, that you can use to build stuff like wind barriers and stuff for fun, or that because they're more compacted, it will melt faster. It might melt faster because it's going to let more sunlight in and conduct heat faster. So it's going more sunlight into like the ground and stuff, instead of reflecting it. Or it might trap in more sunlight if it's dirty, like a dirty ice where it gets trapped, reflecting back and forth in like imperfections. Or you could put in reservoirs and stuff, but that would require significant energy maybe in compacting it, so it might not really be worth it much of the time. But this is more the crazy, outlandish section of ideas. Another idea I have there that's a little more, that's not as outlandish, is just to government fund all this for research and making it. And because I really think the government should fund these ideas and more basic ideas just to make life easier in technology with championships and stuff like that, because the private sector for some reason is not as interested in this. And then you could make the whole development of this cheaper, and the government support it. You could say taxpayers should pay for this, not private companies. And you can make it also not as patentable. And patents really do not help with by technology. Look at, it did not help with penicillin, but that's, and a lot of antibiotics, they get more widely used after patent expires. But also look at a lot of vaccines that are not patented are some of the most widely successful ones, like the polio, or they were patented and the patent distributor used the patent say that everyone gets it for free and kind of anti-patent it. So use the patents to make sure other people can patent it. A lot of programming technology stuff, it's usually when the patent expires that stuff becomes free, or you have a patent and someone says everyone can use it, no matter that there is a patent. Another more outlandish idea is that you could have all this stuff shipped to local reservoirs in the snows, especially if it's ice breaks, so that we can have more water during other times of the year. Yeah, water could build up, and this water would be clearer because it's frozen and it doesn't have as many contaminants, so it'll be more pure water than you usually than from runoff on roads and stuff like that. Another idea about this whole thing is that it could also make it clear up faster by making melt paths, I'm going to call them, but that's just skimming it, doing enough and letting it rest melt. So if you do a 1 foot path and the sun comes out, the 1 foot path has a lot more area that's dark exposed, and it will start melting the sides and make it from a 1 foot path to a 2 foot path or something. So you have two 1 foot paths close to each other, they can easily merge. But you can also do it while it just does a little bit of layer of snow until the point that it can easily melt the things, and you could connect it to weather reports and stuff like that to also better figure out ways and stuff to maximize efficiency and speed of it doing everything. Now, another wonderful idea is maybe this could have guide capabilities. So you could guide you during bad weather, like a virtual seeing eye dog or something, or go in front of you, and you can say, clear out the path in front of me, or something to really help people that are really struggling moving around bad weather in particular. And it could have flashing lights and stuff, so everyone is aware of where it's going. Third idea, the last major idea I want to put out there is you could have this both have an AI system to do it, but also remote control for when it's learning an area or when you want to do something in particular and the instructions are too hard. Now in the future, this remote control could also be not only finger-based, but you could have it text-based, like I talk about text-based controls, spoken controls, and text-based doesn't mean fancy programming. Instead of speaking it and saying it to go left or right. And you could also use this whole system, which this system might have a lot of AI that can learn and be used to teach other people other lessons on how to make AI for future for self-driving cars or text controls or voice control and so much more. Well, thank you for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Also, if any of these for future videos, comments, or suggestions, please leave in the comments section below. It really helps the channel out. Again, thank you very much. Goodbye.